Hello, students, and welcome to our lesson. We're still with our pink and red theme for Valentine's Day this week. I hope you have someone you care about that you can spend some quality time with and maybe do something special. You don't need to spend money, but maybe write a little poem for your mom or someone who takes care of you or your dad. Offer to do an extra chore, maybe do an extra chore and don't even ask, just do it. Surprise them with that. That would be a great thing to do for Valentine's Day. So today we do have a prompt, and our prompt today is about loving your friends, which is an awesome thing to do. And our objective, we are going to learn to combine like terms and expressions. We did some of this, we're doing a little bit more of it. Our central question will be what kinds of terms can be combined and how do I combine variables? So the pages we're going to work on, we'll get down to that. Is we're going to work on this page right here, combining like terms. Okay, I know it says homework on it, but we're going to do it together in class. It's got some great practice. So remember to answer your do now is answered in your class notebook, which is in your Q3 folder. Remember, students, your do now and your exit are done in the class notebook. Everything else is done in the notes. And the only way I know you've done your work is for you to show it to me. So after you complete your page on combining like terms, please make sure that you show it to me. We'll have our exit ticket to do at the end. Again, show me your work. If for some reason you cannot, send a picture then. You can upload Teams on your phone. It makes that process really easy. So that's your exit. If you have not finished, if you don't get to finish the lesson during our class time, you can always do it for homework. So remember, camera on, respond when your name is called at the beginning, middle, or end of the period. Show your work on camera at the end of the period. If there's a problem with your camera, send me a photo and there's my email address. And remember, students, a job well done means a job done honestly. Please respect the honor code when working online. You're doing your own work. Try to think the problems through on your own without looking up the answer. And you don't need to do that because I do all the problems for you. Make sure you pause that video and try some of them on your own. I hope you think this is beautiful. I tried to find something really special for Valentine's Day, so I found this pretty border. If you have a border you'd like to design for me, be happy to use it in our Do Now, so just let me know. So our Do Now prompt is good friends can love each other. How can sharing beliefs and imperfections help friends develop this deep caring? So we always think of our friends, I think, as well, they go to the same school or they're in the same grade. Maybe they go to my club or swim with me, somebody on my swim team or our football team, or I go to my same church or something. But, you know, sometimes it's the imperfections, not just the things that are the same, but the imperfections that can help us appreciate and care for each other. So if you know that somebody's going through a particular struggle or a challenge, and you think, well, you know what? I didn't know that about them, and I didn't know they were battling that thing. It could be a physical challenge or an emotional or mental challenge, and knowing that imperfection can actually help you become closer as friends. Sometimes when we share our warts and our flaws, we learn to love each other a little bit more. So if you have a thought about this, please put it right there. We'll get back to our exit ticket in a minute. But for now, we are going to combine some like terms. So put your name at the top and let's get this done. So we are going to look at the expressions. And when we look at these expressions, we'll look for variable terms. We'll look for constant terms. Those are the numbers that are all by themselves. And with the variable terms, if the variable terms have a number associated with the variable, that number is called a coefficient. So our first expression is 7k minus 8k. So our variable terms are 7k and 8k. There's no constant, but the coefficients are 7. And remember, this is a negative 8. I say it all the time. I'm going to say it again. Subtraction operates the same way as a negative. So we take that negative and we assign it to the 8. It's not just 7k minus 8k, which would produce the same result. It functions the same way. It operates the same way, I should say. But when we list out the coefficient, we're going to call it a negative 8, okay? Let's move on to the next one. We have 1 minus 3m plus 14. The only variable term there is the negative 3m. Same rule with the negative. It goes with the 3m. The constant terms, those numbers by themselves without variables, are 1 and 14. And those are both positive, but in this context, we do not need to put the positive symbol. We would need to put the negative symbol though. But the coefficient is the negative 3 in front of m, so our only coefficient is negative 3. So why don't you try 3, 4, 5, and 6 on your own and then come back to the video. Okay, number 3, our next expression is 5y plus 2y minus 7 plus y. Okay, there's a tricky thing here. You'll see it in a minute. First of all, our variable terms are 5y, 2y, and y. Our constant, our number all by itself, is the negative 7. Our coefficients are 5 and 2, and, wait for it, we have an invisible 1 in front of that y. So 1 is also a coefficient. I hope you got that. That's one of the keys to always adding and subtracting your equations correctly in algebra, especially when you get to systems, is understanding how that invisible 1 works in front of a variable. Sometimes you'll add it, as in this case, and sometimes it will be subtracted. Moving on to number 4, we have negative 19 plus 4 minus 2w plus 7 minus 11w. So our variable terms, there are 2 of them. We have negative 2w and negative 11w. The constant terms are that negative 19, 4, and 7. The coefficients here are negative 2 and negative 11. They're both negative. So let's move on to number 5. Our expression is 3a minus 2b minus b plus 10a minus 16. So our variable terms are pretty much everything but the minus 16. So we've got 3a, negative 2b, negative b, and the 10a, which is positive. The only constant term is the negative 16, but the coefficients are 3, that's in front of the a, the negative 2 in front of the b, and then we have another invisible 1, and this time this is a negative 1. Hope you caught that. And then the 10 that is in front of the 10a. And then number 6, we have negative n plus 4m minus 27 minus 3m plus 2n. So our variable terms are negative n, and that will be an invisible 1 in front of there. We have 4m, negative 3m, and 2n. Our constant term would be simply that negative 27 right there in the middle, and our coefficients are the invisible negative 1 in front of the n, 4, the negative 3, and the 2. Okay, now we're going to put it together. We're going to put it to work. We're going to actually simplify these expressions by combining like terms. So we have negative x plus 8x. Remember, that is negative 1 plus 8. Okay, and then we have to carry the x through. So that would be 7x. 16 minus 2v plus 3 would be negative 2v. We put a variable term first, and 16 plus 3 is 19. Now we have 7p minus 11 plus p minus 15. So we have an invisible 1 here. So 7 plus 1, we have 8p. Then we have negative 11 minus 15, which is negative 26. Let's box our answers. Number 10, negative 3y minus 2 minus 3 plus 17y. So negative 3y plus 17y equal 14y. And negative 2 minus 3 is negative 5. Number 11, 8m minus 5 minus m, and that's an invisible 1, minus 8. So 8 minus 1, that's 7m. Negative 5 minus 8 is negative 13. And number 12, we have negative 4k plus 11 minus 4k plus 14. So negative 4k minus 4k is negative 8k. 11 plus 14 is a positive 25. And number 13, negative 1 minus w, which is an invisible negative 1w, minus 2w plus 7 minus 19. So negative 1w minus 2w is negative 3w. And then negative 1 plus 7 minus 19 is negative 13. Number 14, 34 minus 11c minus 7 plus 2c. We'll start with the variable terms. Negative 11c plus 2c is negative 9c. And then 34 minus 7 is 27, and that's still positive. So hope you can try the next 6 on your own and then come back to the video and see how you did. So pause the video and try them on your own. Okay, I hope you tried them on your own. Number 15, all of the terms are variable terms. We have 2 different variables. We have m and we have n. We have 6m minus n, and there's an invisible 1, plus 5n minus 5m. So 6m minus 5m is 1m, and that will become an invisible 1. So it's m. So we took care of those. And we have negative 1n plus 5n, and that would be 4n. And that's our final answer, m plus 4n. Number 16, we have 7r plus 3r minus 15s minus 10r plus 8s. So let's go through this. Let's start with the r's. We have 7 plus 3, that's 10r, minus 10r, that gives us 0r. Well, we don't write 0r. We just leave it out. So we don't have to write anything yet. Okay, so we don't have to write anything. And we've got negative 15s plus 8s, which would be negative 7s. And that's the entire answer. How'd you do? So it's number 17. We're getting a little more complicated. Negative 14 minus 2x minus 10 plus 3y plus 8x minus 16y. So let's start with the x terms. Negative 2 plus 8 would be 6x. And let's go with the y terms. 3y minus 16y is negative 13y. And then the constants, we have negative 14 minus 10, which is negative 24. And let's move on to number 18. We have 6b minus 4a plus 4a minus 17b plus b. So this is similar to number 16. We have minus 4a plus 4a. So 4 minus 4 equals 0. So we don't put the a's at all. They're gone. We have 6b minus 17b plus 1b. So 6 plus 1 is 7. Addition is commutative. Then we have that negative 17. So 7 minus 17 is negative 10b. And finally, number 19, negative 7b plus 15 minus 2q plus 11q minus 2p minus 3. So we'll start with p because it comes before q in the alphabet. We have negative 7 minus, oops, that's a q, negative 7 plus 11, and that's it. Nope, that's a q. Sorry about that. The print's a little small for me. Let's start over. Negative 7p minus 2p is negative 9p. Now, negative 2q plus 11q is positive 9q. And then we have 15 minus 3, which is 12. And our last problem, we're going to have to do a little bit of work for this one, okay? 8 plus 2/3 k minus 4/15 k minus 1/4. So let's just look at the k terms. So we have 2/3 k minus 4/15 k. So we're going to have to convert this to 15ths. So 3 times 5 is 15, 2 times 5 is 10. 10 15ths minus 4 15ths is 6 15ths, which we can reduce to 2/5. So that's 2/5 k. Okay, that took care of the k's. Now we have 8. I'm going to work over here. We have 8 minus 1/4, and we're going to have to convert this to, sorry about that, we're going to have to convert this to fourths. So 1 times 4 is 4. Yeah, okay, I thought I was reading the problem wrong. 1 times 4 is 4. 8 times 4 is 32, so it's 32 fourths minus 1/4, which equals 31 fourths. We'll leave it as an improper fraction. So it's 2/5 k minus, or plus, because when we subtracted 1/4 from 32 fourths, we have a positive 31 fourths. And that's our final answer, 2/5 k plus 31 fourths. If you need a little extra practice on those fractions, make sure you let me know. But remember, our rule is that when we add or subtract fractions, we have to have like denominators. So make sure you know your multiplication facts. So let's go back to our exit ticket, and it asks the question or the statement, I can combine variables if they are alike, meaning they have to be the same. If not, they must remain separate. Okay, so thank you for enjoying all of our beautiful Valentine's decorations all week. I think it's been kind of fun. If you'd like to, again, make some pretty page borders for me to use in our do nows, I'd love to do that. It doesn't have to be a contest. You can just make them and show them to me, and we'll work with that. So thank you for working hard. Thank you for being patient. Thank you for answering do nows, filling out your exit tickets, most of all for working hard in your math and for showing your work in our meetings. Have a wonderful day. And remember, with practice, you'll be great.